So today we have Emily Gavrilenko from Roboflow. So from interning at Amazon to working at Goldman Sachs and then serving as a CEO of Ride, and developing cutting-edge computer vision solutions as a software engineer at Roboflow. Emily has done it all. So today we can join her for a deep dive into computer vision, and then you can follow her workshop and then do your own after today. And then we're going to end that with a Q&A with the community. So Emily, thank you so much for hopping on to the webinar today.
Happy to be here. Let me share my screen and we can get started.
Very interesting background. So you used to be in investment banking, Goldman Sachs, and then a founder, and now in CV. So what took you from one place to the next?
Well, to clarify, I did not do investment banking. I did fraud detection. So still an engineer there. But yeah, initially actually started off in mechanical engineering. My first job was doing HVAC, so heating and cooling for buildings. And one of the projects I worked on was heating and cooling for Google. And I remember asking my manager, I'm like, oh, what is this? And he was like, oh, that's the rock climbing wall. I was like, oh, what's this in this blueprint? He's like, oh, sleeping pods. And that was kind of when I realized I would rather be in the building than outside of it. And especially working on the brains rather than the body of these machines. So switched my major to computer science and kind of started off my journey trying to figure out what was the most interesting field. And initially kind of landed my first internship at Amazon, and I was working kind of on their robotics RoboMaker team. And so was kind of imagining Roomba having that, and rather than testing Roombas in a million different houses, they simulate it in a million simulated homes. And so I was working on kind of helping collect and analyze customer data on the service, but realized I was kind of pigeonholed into doing a very small part on a very big team and a very big organization. So kind of wanted a bit more autonomy and having a bigger picture. And so at Goldman Sachs, I kind of led my own project from end to end, kind of talking to key stakeholders. And I really enjoyed that. But I think still was kind of felt a little trapped in these big companies and wanted to do my own thing, have a lot more autonomy. And so decided kind of to start my own business. That was something I was exploring and met the right co-founders. And so at Ride, I was still in college at the time, but we built a long distance carpooling marketplace. So connecting riders and drivers, they would be doing long distance rides, maybe 200 to 500 miles. And people would post oh, I'm going from point A to point B on this date, chip in for gas and I'll give you a ride. And we ended up having thousands of people using the platform. And it was really cool to see the community of people met their future roommates on this platform. People were able to see their friends more, their family more, but ultimately didn't see a way to bring that to profitability. It was a lot of work and very kind of low payoff. So I started to see this huge emerging trend of AI and really wanted to get in. Was interested in computer vision specifically because I really love combining the visual experience, making good intuitive UI with actually programming as well. So found my way to Roboflow, and that's what I've been doing since.
It makes perfect sense now.
Yeah. Sweet. Kind of did my brief intro already, so I'll kind of skip over it. But yeah, my name is Emily. I did computer science at Cal Poly, was a former founder, and now I'm doing computer vision at Roboflow. And so kind of what is computer vision? It's enabling computers to have the sense of sight. And so actually going through and being able to detect, given a video or an image, what's inside of it. There's varying degrees of confidence so that you can be using that to make the models better over time. And then ultimately, after you actually see something, you want to get some insights out of it. So how many objects did you see? Kind of maybe you want to send notifications if you're something specific is happening. And so we're all enabling all of that with computer vision at Roboflow. So yeah, computers will soon use sight as a primary input. So that's what we're doing here at Roboflow. This is kind of what started the company in the first place. Our two co-founders made the Sudoku solver, where you can actually drag a camera over a Sudoku puzzle and actually go ahead and implement the logic to solve it for yourself. And so many new use cases are enabled through this. We have everyone from kind of natural conservatories, like tracking impacts on wildlife. They built a dam and they're looking to see how many are going through the landscape. Are they bigger, smaller? Are they healthy looking? To everything from a lot of manufacturers actually doing defect detection to make sure all our cars, all our goods are actually getting to us in one piece. And that's what computer vision does. And so kind of a lot of different parts of the process. One is you actually need to collect data, whether you have images or you have video coming in. And then you want to actually go ahead, figure out what is the data that's most relevant. kind of golden rule of computer vision is you want your training data to match your production data as much as possible. So garbage in will equal garbage out. So that's a very important step. And you actually want to annotate those images. So actually specify what is in it. Is this a car? Is this a person? Is this a self-driving car? And kind of the model is able to, based on that data, actually learn and tell differences between them. And then, yeah, once you have all that data, you actually want to go ahead and train the model. So picking off a process, we have a lot of both like YOLO processes, which YOLO stands for you only look once. Like it just passes through, looks at the image, and is able to identify all the characteristics of that image and all the different properties of what is inside. And then obviously, once you have the model, you actually want to do something with it. So that's actually running deployment, and Alec can show you how you would go ahead and go through the whole process. But before I did that, I kind of wanted to show you the power of computer vision. I have kind of a fun web app I created during my first week at Roboflow, where you actually get to upload a file. Here, I have my music player, so you can identify the music notes. So this is running computer vision on the model I trained, and it's identifying what is in the image. So now you can see here, I actually found all the different notes, identified they were different, and returned back the classes. So did you hear that all right?
Yeah, it's very like a synth wave happy birthday.
Yeah. So that's a robot attempting to play Happy Birthday. So that was kind of a fun intro, but yeah, let's talk about how I actually did that. So much stuff to show. So yeah, kind of looking at a step. One, you kind of start off with your projects, which is a collection of the data you see here. Jumping into the music player, kind of getting started. First, you specify what you actually want to identify. And in this case, I was a musician, so I have a specific class for every music note. This is how I kind of denote the first part is the actual sound that's coming out. And so imagining do, re, mi, fa, sol, la, ti, each one has a different annotation here. And then the second part is actually the length. So one means it will take up one whole measure. This means it will take up half a measure, and so on and so forth. So classes mean different things. In some cases, the class could be a car. In other cases, it might be person. You might want to identify between different animals, so cat, dog. So this is kind of where you'd start off. After that, you go ahead and upload images, and then fun part of actually annotating them. And so here you can see I spent a lot of time actually going through and specifying, okay, each single note in this image represents the specific class. Kind of the power here, though, is once you maybe label 5 images, you can actually use label assist. And so this will use a model on Roboflow to actually go ahead and speed up annotation. So let's say I mark this one as null, but then I actually go ahead and use this model I have trained. And so I'm using my sheet music player. Let's say I want to use this version. Can actually go ahead and run my model on this image.
So how many do you have to label by yourself until you can do like auto labeling?
Yeah, so it kind of depends on the data you're using. And so, of course, this demo, you can never have a demo not go wrong. But let's say you're only detecting cars. Maybe once you have 40 examples of a car, then it will actually be good. In this case, since I have so many different notes, and so you can see here, cool, it like already sped up my process by 2/3. And you can even like play around with the confidence. If I jump up some more, it'll actually find more annotations. And so this is kind of really powerful way to leverage human knowledge to actually get you to the responses faster. One thing to note here, since like every single note is different, I did have to label more images so I'd have examples of every kind of note per se. But yeah, I like after 7 images, I trained a model and it worked great. Sometimes if you have 1 car per image, you might need maybe 100 cars so you have enough examples for it to generalize on. And then, yeah, once you have analytics, you can kind of see what are the most common classes. And so this is kind of the most standard base note. There's a lot of them. But if you actually go and look towards the end, you can see some of the classes only have 1 instance. And that's because maybe these are very rare notes. They're not seen a lot. So obviously the model will perform worse on them. And to make this model better over time, I'd want to add more examples. There's also different ways to view the distribution of like the images I'm seeing. So yeah, once I have data I feel pretty good at, we can generate a new version. And so this is specifying, okay, let's say for my music note, I want to convert it to grayscale since color doesn't really matter. But if you want it, and this will make the model predictions a bit better. And then you can actually generate augmentations. And so this kind of gives you more examples to train on that captures the environment you're seeing. So I'm imagining if a user uploads any image, they could be rotated a bit, the brightness can vary, might be a bit more blurry. And so this captures more of the environment that I'll actually be seeing in the real world as my model is running. And then, yeah, once you have a version, it will kind of look something like this. You have all the images. Well, this was a bit different. I was playing around with something. But typically, you'll have one version where it has the image that you've annotated. And so then you would go ahead and train a model. You can actually use different models and play around and see which one works better for your use case. You can train faster models. That's typically recommended if you wanted to get something really fast to start auto-labeling. If you have more time, you can do more accurate models, and that just uses a bigger model weights. The inference will be slower, so it kind of depends what you're looking at. Typically, you start off training from Coco, which is the most common classes. So the model was pre-trained on animals, people, vehicles, and is actually learned what is an edge, what is light versus dark. So kind of those key characteristics, but you'll actually want to fine tune it on your own data so it's able to learn your customer classes. And actually, once you train it once, then you can use your previous model that you've trained. And it already has knowledge, what is a music note? And it's kind of just fine tuning it and improving over time on your own data. And then cool, once you train, you'll have a model. You can actually try it on your data, play around, and immediately start seeing the results. So now it's actually calling a model, getting predictions, and you can play around with the confidence to get the responses back. And then you can also see model evaluation and see how does the performance, like where is the model doing well, where is it struggling on, and evaluate it there. So now it's actually currently computing the results.
So once you have like a fine tune or a trained model that based on your own data, does this turn into like an API endpoint that you can just hit?
Yep. Yeah. So then once you have this, you can actually go ahead. You have an API endpoint. You can view the code. I'm going to refrain from doing that because it has my API keys. And then, yeah, you can actually go ahead and use it in your different workflows. One other cool thing that we've currently have been building out is this workflows feature. And so this is where you can actually combine your models with a bunch of logic to actually get the value that you want to get. So we recently launched a bunch of support for videos, for example. And so here I'm doing a rock, paper, scissors. What it actually does is it actually detects how long you're holding up a rock on the screen. And it actually is able to say, like, for example, like before, if you were trying to count car, every single frame, each car would increase the count by 1, whereas it's the same object. So doing these stateful analytics actually lets you do more advanced logic and computing, just directly configure it here and run it in 10 lines of code. So yeah, I can build a fun workflow real quick for you guys. I'm going to add something to blur faces. So you can do 2 different ways. You can actually deploy your models. So this kind of exposes an API endpoint you can use your models with, or you can explore public models. And so we have Roboflow Universe, where it's all the community models that members have built. I'm actually going to go ahead and, like, let's say, filter out by models that have at least 5 stars. As actually loading the results. And you can see here, like, okay, we have some face detection models. We have one that looks at football fields, emotions, people detection. So this kind of gives you a quick way to even jump in and get started with stuff people have built without spending all the time labeling and training data. And you can actually use it to find interesting data to train with. So for example, here's the cash counter. You already have all these images that no one have labeled. Okay, what is a coin? What is a dial? It started faster. But yeah, jumping back into workflows, let's say, let me see what I want to do. Well, let's say I want to do face detection. I can actually just drop in this model. I can add, let's say I want to add a visualization. So this will build a box around it. But also, let's say I want to build something that blurs people's faces. And so this, I kind of have my workflow. If I want to test it, I can select a file. Let me try to find a good image. I guess I have a fun one with me and my coworker playing rock, paper, scissors. And so now you can kind of see the models, the raw predictions. So this is calling an API endpoint. You can kind of see it here. It's calling detect.roboflow.com along with kind of the model that you built. And then going from there, it actually returns the raw prediction. So you can see here, it has the location, the confidence, the class detected, but it actually not only returns that, but you can actually get raw images from the results. So here it found the faces, and here it actually blurred the faces. And there's a lot of customization. So you can actually go on the blur, increase the blur factor. Let's say I'll increase it to 100. Now I can test it again. Lets you quickly see, okay, now this blur space is a lot. I like this solves my need. Then you can actually go ahead, deploy it, get the public endpoint, and make it available to all your users. So yeah, that's, I guess, what I had prepared. Any questions?
Amazing. This is great because I've been procrastinating on learning how to use Roboflow, and that just gave me all the things that I needed. And I get to ask you questions directly, so that's awesome. So I have a question for you. So a lot of our community members, and myself included, we're more used to using like LLMs and like visual models, especially like Llama 3.2 came out like literally yesterday, and now it has like vision capabilities. Most of us aren't very familiar with like the YOLO family of things. So how would you explain YOLO to somebody who only knows like how to deal with large language models and NLP?
Yeah. So like kind of the power of Roboflow is it combines the two. And so the way we envision it is like these generalizable models kind of have the intelligence of maybe a 7-year-old. So it knows the more common objects. It knows what a person is. It might know what a car is. It typically won't know what like very specific use cases. So if you want to know, okay, does my Boeing airplane have all the bolts? Maybe it's not able to answer that question for you. And so in that case, like you want to actually fine tune it on your data, something that the large language model hasn't seen. Other common use cases where it's really powerful on is, let's say I want to read the license plate on a car. Well, I feed in the raw image, it doesn't really know where to look at. Whereas if I kind of can combine this with a YOLO model, I can train it, this is a car, crop to the license plate itself, and then pass it to the large language model. That kind of fusion gives you a lot more power and capability. Another kind of quick win is if you want to run it on a live video, you can't really do that. These large language models take so long. So we've really seen the intersection work really well. So a lot of people kind of start off labeling their data with these large language models. So a lot of the new suites of tools we've featured include these automatic labeling tools. So you would start off kind of using these VLMs, so vision language models, annotating your data, then training this much smaller model that runs a lot faster, a lot cheaper, and that is like really a domain expert in what you're trying to do.
Makes total sense. So you must have seen a lot of projects that either your clients have built or people have built using Roboflow. What are some like maybe top 3 that kind of stood out to you that you remember?
Can you say that one more time? It kind of broke out for a second.
So you've seen a lot of projects being built with Roboflow, right? So like top 3 projects that you've seen that makes you go like, wow, like this is like insane.
Sorry. I was just at a customer on site, and it was checking to see like they were building the shingles that go on people's homes, so on your roofs, and they have a roll of like plexiglass that comes in and packaged shingles that come out at the end. And this whole process takes like 2 minutes. It goes down this 500-foot assembly line, comes out fully assembled at the end. But for their end, like sometimes defects happen, and maybe sometimes the wrong colors are there, and your roof will have an incorrect color palette, so it'll be light gray, light gray, light gray, slightly darker, and it's like very noticeable. So in their case, they were doing like color detection, and so combining both like traditional computer vision, like what's the dominant color, with these object detection and YOLO models to kind of be able to ensure they're releasing good quality products. That's kind of recency bias. I talked to them recently. Another really cool one is kind of working on like chocolate QA. So making sure that the chocolates come to you perfectly round, not stuck together. That's really cool to see just a bunch of chocolates whipping up on the assembly line. In terms of more like kind of, so those are, we work with both enterprises and everyday kind of startups working with vision. A really cool one, or just interesting stuff, like people are like building walnuts and they want to see like, okay, is this a 16 millimeter walnut or an 18 millimeter? And so just looking at the size, had a call where they were, yeah, a lot of these are recency bias, the people I talked to recently, but they were also just like looking at the sky and trying to detect cloud cover. So to make sure that the weather analyses reports on our phones are more accurate. So combining kind of temperature data with this visual data to tell you if the clouds are out there or not. So yeah, some of the fun use cases of vision.
That's awesome. I literally just came back from this like expo thing here in Ottawa, and there were a bunch of companies that do like drone like stuff, and one of them does drone for roof inspections because you mentioned shingles. So like, so what they do is they fly these drones out, and because as a property manager, like you get a bunch of properties you have to inspect, and if you have like you're a homeowner, you can put your ladder up and go onto your roof. You can inspect that. It's fine, but if you have like hundreds of properties, what you can do is you can use their drone. And I'm assuming they're doing something similar here, where they're like taking pictures of things and then like trying to detect like misconfigurations or like durations and stuff like that. So I just saw that like today too. So like recent bias as well.
Yeah, there's a lot of companies actually trying to do solar panel defect inspection with drones. Since there's so many huge solar fields miles wide, you can't really have someone going up and down each row. So automating that process, make sure like we even can get our energy efficiently.
Awesome. What excites you the most? Like this is not like, this is personally to you. Like in terms of computer vision, what do you think is like the most exciting thing for the next like year, 2 years, 5 years, stuff like that?
I think like language has seen a huge boost in like models coming out. So just seeing like the wave of productivity and like the power these large language models have, I think vision is just reaching that point where these large like VLMs are able to perform a lot of like the complex reasoning. And so it saves people, like rather than going through and spending days, weeks training a model on your data, how can we like make that as fast as possible? So day one, you can use this like VLM and get to value, like almost deploy first and like start collecting data already pre-annotated and get to value that much faster. And I think that's kind of where the world's moving, and it's really cool to see all the trends there.
Perfect. Okay, so last 3 minutes, we want to open up the floor to anybody from the community to ask Emily any questions. Okay, you go first. Whoever just raise their hand.
Hey, thank you so much. Hey, thank you so much, Emily, for the presentation. I enjoyed it quite thoroughly. I have one question. I'm just wondering about the limitation of the web app that you showed. Like, have you tried using more than 100 or 1,000 images for annotation and training? And if you have any desktop app that would complement it.
Yeah.
Thank you.
Yeah. So like most, like we support, like we have users working with hundreds of thousands of images and tens of thousands of classes. I'd say like 10,000 classes is probably the limit. After that, we kind of see two-stage model where the first one detects like, okay, where is the music note? And then the second, or it says like, okay, what is the direction of the note? And then the second one detects what's the value. So kind of combining two different models is really powerful in there. But yeah, limitations, you can do like a lot of classes, a lot of images.
Okay, thank you.
Cool.
Yeah,
I think Mike.
interesting stuff. Sorry, I'm gonna add one more thing. We have a lot of people doing like grocery store. So you can imagine like Walmart has 125,000 SKUs, unique products, and they were working like on an automatic checkout. So you would put your grocery cart under a camera and it would detect all the items in your cart and like automatically generate a receipt. And so for them, they had definitely lots of classes. But yeah, Michael, on to you.
Thanks. I have a classification task where I need to find things in Street View imagery, like stop signs, road signs, whatever. And I can get YOLO V8 to actually find the things, and I'm happy creating new classes. But the next obvious thing is locating where that mask actually sits in real space. So the camera actually knows where it is. It has a GPS, it has a bearing. But are there any connections between YOLO V8 and this universe thing that you just showed? It looks so cool. But specifically, you have a series of images, say 5 to 10 of the same object. Is there a really easy way to do the structure for motion so you can, calibrate your camera and find out where the object is using the kind of parallax of like series of images?
Yeah, that's something we're kind of exploring right now. Short answer is off the bat, no. Medium answer is coming soon. And so I think traditionally it was you would get your predictions and you would do the logic. So we're building a lot of more of that inside the app. But for that, like if your camera has geospatial coordinates, then you can kind of extrapolate the distance and the size.
Yeah. So far, that's what I've just been doing is I can use camera calibration and figure out where it is, and then just from the bearing and the distance. But it's not ideal. Like the ideal is you use a series of images and you actually pinpoint the intersection of the trajectories.
Cool. I do have to run to another call, but yeah, it was great talking to all of you and really enjoyed presenting.